20, we're the power consumption group, and my name's Gabby.
I'm Talani.
I'm Tulip right away.
For our group, like I said, we chose power consumption. We imported all of our things we needed for this project, like our NumPy, Pandas, and Seaborn. For our analysis part, we imported our power consumption data, which was given to us. The first part is just kind of like a summary. It just lets us know like the beginning and our last data. Then we have our information. We run a code for it to describe it to us. So it's just mostly like a summary of our data. And then we did our plots. That way we have like a visual of our data. We have temperature, humidity, wind speed as your features, and then we have our zone 1, 2, and 3 as our zones. After that, we did a heat map. For a heat map, our base correlation is temperature. Like we can see it's like our darkest numbers. For zone 1, 2, and 3, temperature will be our biggest correlation out of our 3 features.
So our first model is using multiple linear regression. Here we can see our features and then our zones. And then we plotted it using the sklearn library. First we plotted the training set, and then we plotted our testing set, and we did this for each zone 1, 2, and 3. And we used the R-squared value to predict the accuracy, and then root mean squared shows how accurate the training set versus the test set are and how close they are to each other, which you can see is very close. So for zone 1, we have 0.20% accuracy. And then zone 2, we ran the code again using both training and testing set, and you can see an accuracy value of 0.16. Again, the root mean squared values are close. And for zone 3, we have an R-squared value of 0.24, which is one of our highest accuracy values.
For our power law model, so our power law and multiple linear regression models are really similar. Just our power law is not linear. It just lets us see like a broad variety between our temperature or humidity and our wind. Like we can see like our they're not linear. They're like kind of like a broader data. Our temperature is mostly like the one that's our most accurate data. We did this for zone 1. We did our temperature versus zone 1, and then we did our temperature versus log power just to see what we were looking at, just to see like what we could predict. And then for our power law model, or our square number is 0.20, which isn't bad. Like I said, we notice like our temperature is always like our highest value.
For the exponential data model, the R squared was 0.227, and the standard errors assume that the covariance matrix of the errors is correctly specified. The dataset example we have here, the predictions are: the test case 1, temperature is equal to 12.5, the humidity is equal to 21.8, wind speed is equal to 17.9, and predicted power is 17,664.997. The test case number 2, temperature is 71.0, humidity is 85.2, wind speed is 54.0, and the predicted power is 53,503.509. In test case number 3, temperature is 0.073, humidity is 0.068, and the wind speed is 0.083, and the predicted power is 8,359.60. And
So overall, for our explanation, out of the 3 models, we found that the linear regression model works the best. It had like the highest accuracy number for temperature. Overall, like we said, like for correlation, our temperature is highest. It helps us visualize more like our power consumption. That's it. Thank you very much.